Hi guys, good afternoon. So we're gonna work through this paper. As you know, we set a very low pass mark on it because we know it's the very first one, and we expect that we will improve over time, on the exam. And so the exercise today is for you to look at the solutions, learn from the mistakes, and the question that you didn't get correct. It is a must that you redo those questions. Right? That is how the learning process works. Any question that you didn't get correct, you have to go and redo it. All right. The aim is to complete 24 mock exams between now and the actual exam. And hope that by the time we get to that stage, 95% will be easy for you to get on a paper. The target for this one is just 25% because I expect a lot of mistakes and stuff. And we are all marking right and wrong. So even though some of your steps in the process might be correct, we are marking right and wrong. That's why the pass mark is so low. All right. All right, guys. So this is the June 2017 exam paper. All right. Want to finish it as quickly as possible and as efficiently as possible. By the way, online can hear me? Can see the screen? People online can hear me?
Yes, sir.
All right, yes, sir. Good. All right, so let's do this. All right. All right, so the first question, as always, is a calculator question. Where they tell you to use a calculator most of the time to answer to find some numeric value. All right. So here we have it. It says you have to use a calculator or otherwise to calculate the exact value of this thing. So the matter of typing this thing in the calculator exactly as it appears there. And this is why I keep emphasizing the need to get one of those calculators that you can type this in and it appears exactly as it does there. Call it a textbook display calculator. You need to get one of those if you don't yet have one. So it starts out with a bracket. It's a mixed number, 4 1/3. It's a matter of entering it correctly. And then we are subtracting another mixed number, 1 2/5. Close that bracket. And they were dividing by a fraction, 4/5. 4 over 15. Then it's a matter of checking that what we entered in the calculator is the exact thing that we have there. And you know, sometimes your finger can miss a button and stuff. So I just want to ensure that it is the exact same thing. Simply because we're not going to be showing steps. We're going to just be writing down the answer. You will have to absolutely make sure. All right? And I'm getting 11. So I'm suspecting that you all got 11 as well. That's the exact value. Mute your mic, please, online. Mute your mic online, please. Answer for this one is 11. All right? 2 marks down. Somebody online is nice. Mute your mic online, please. Mute your mic. Jesus. All right, let's go. Next one is for us to enter this one in the calculator. So let's clear the calculator, make sure you clear it fully. And we're going to enter it exactly as it appears there. So it's an open bracket, 3.1. Then we're subtracting 1.15. Close that bracket. Square that overall thing. And then we're dividing that by 0.005. And that works out to be 760.5. 760.5. 2 marks for that as well. All right? So you're going 4 marks already at 25. Let's continue. Then we'll come to this question. This is some consumer arithmetic question. Normally very common sense questions. It says a store is promoting a new mobile phone under 2 plans. Plan A and Plan B. It says plans are advertised as shown in the table below. So this is the column for Plan A. This is the column for Plan B. These are the components of the plan. So you make a deposit, for example, of $400 on Plan A, and they make monthly payments of $65. I'm making those monthly payments for 12 months, and then there's no additional charge. There's no tax to be added. All right, and that's how we would calculate the cost of the phone on the Plan A. On the Plan B, the deposit would be $600. Then you'll be paying a monthly installment of $80, and you're only paying that for 6 months. But at the end, you have to apply a tax on the total of 5%. So you add a tax of 5%. So to add a tax of 5%, we can just calculate 105%. We don't need to calculate the tax if they don't ask for the tax. All right, so let's get into the question now. First part wants us to calculate the cost of the phone under Plan A. And we can just write out what it's going to be. It's not complicated. So the cost of the plan under Plan A, you can call it Plan A cost, is going to be equal to the deposit, $400, plus we're going to pay this $65 12 times. So we're going to add 12 times $65. And basically that is it. Whatever that works out to is the answer. All right? Because we're not adding any tax. And so if we work that out, it's going to be 400 plus 12 times 65. I don't have to work out this part separately. I can just put the final answer there. It's 1180. 1180 is the cost of the phone under Plan A. But to go to that, nice and easy. Next part says, determine which plan, Plan A or Plan B, is a better deal. So the better deal is the one that they're going to get the phone for less, right? So since we already know what we're paying for it under Plan A, we don't need to work out what we're paying for it under Plan B, and then we select the cheaper one, the one that we're paying less, as a better plan, right? Everybody wants to spend less money for anything. So let's work out the Plan B cost so we can make the comparison. So let's look at it this way now. Plan B cost. Because we're going to do the mathematics easy way now. It's going to be equal to, because I know that I need to add a 5% tax, I'm going to work out what the amount is before tax. And when I add a 5% tax, it means that I am doing 105% of the total. You have to do the mathematics the easy way. You don't have to work out the tax separately and then go back and add it. All right? So the cost of it is going to be the deposit of $600. Let's put that in first. Plus, you're going to pay this $80 6 times. So you're going to add 6 times $80. Let's put the dollar sign on it. That's going to be the total before tax. But then you're adding a 5% tax. So to add a 5% tax, I can simply multiply by 105% to get the final value. If you don't do it that way, you can't get the 5% and then add it, it's the same answer you're going to get. But this is for us to do the calculation using the least number of calculations as possible. We don't want to do too many calculations. All right? We need to understand these things. So I'm going to work it out this way. So I'm going to put the bracket. I'm going to do the 600 plus the 6 times 80. Close back the bracket. And I'm going to multiply that by 105%. 105%. And it tells me that I'm paying for this one 1134, which is cheaper. So Plan A is the better one because it is cheaper. So justify your answer. So Plan B is better because it is cheaper. Plan B is better. It's a better plan, right? So which one is better? It's a better deal. Because it is cheaper. Comes out for less. So it's a cheaper deal. So, but I got that one. Anybody did this part another way and get the 1134? Huh? You get the 1138? And they do the 6 times this, and that gives you 480. And you have to add the 5% to that as well. If you do that, you're going to get the same answer. But you see, you're doing a lot of work unnecessarily. So that's why you have to learn to do the mathematics here. But do you understand this calculation? That's the point. You see, notice, you don't get a lot of space to work with, guys. You don't get a lot of space to work with. They don't expect you to be doing 10 calculations when you can do it in 1 calculation or 2 calculations. All right? So we have to learn these things. So remember, if something increases in value by 5% because of a 5% tax, it means that the final value is 105%. And so we can do it that way. There's no need to calculate the 5% and then turn around and add it. We can just get the final figure by just calculating 105%. So this would have been the amount paid inside here. Inside here, mark it in red. Inside here would be the amount paid for plan B before the tax. But because they're adding a 5%, we multiply that amount by 105%. 105% is the same as to add 5% on a figure. Multiply by 105%. 105% is 1.05 as our value. Online, everybody okay with that? Or the 12 persons online. Everybody okay with that? Yesterday we had about 25 persons online. Everybody okay with that?
Yes, sir.
All right, let's move on. That is that. Then we'll come to part C. That's why I call this question the meter paper. I don't want any talk. If I'm talking and disturb the class, I'm going to ask them to leave. I'm going to tell the parents why I'm asking them to leave. And who I'm asking to leave. It's serious time now. All right. Question says, John's monthly electricity bill is based on the number of kilowatt of electricity that he consumes for that month. He says he is charged this amount, $5.10 per kilowatt hour. So for every kilowatt hour that he uses, he pays $5.10. It says for the month of March 2016, 2 meter readings were displayed. This is at the beginning. This one is at the beginning. So its meter reading at the beginning was this. And at the end, it was this. So clearly there's an increase. The increase is in these two numbers. Because here is 3,000. The increase is the difference of those two numbers. All right? That represents the increase. All right? So let's do what that increase was, and let's see what the question is. The question is, calculate the total amount that he pays for electricity consumption in the month of March. So the amount that he pays is going to be equal to the amount that he used or consumed, which is the difference of these two numbers. But I don't have to go up to the 3,000. I can just take the difference of these two numbers, multiply by the rate. I'm going to do it in one calculation again. I am in class. I am in class. I am in class. All right. So the calculation is this. The amount that he pays is going to be the amount that he consumed. I'm just going to calculate it, which is this figure minus this figure. 307 minus, this is really 11. And you multiply that amount that he consumed by the rate, which is $5.10. But understand that? Very good? So let's do that calculation quick and fast. We don't have to answer what they don't ask us. So it's 307 minus 11, close bracket, times $5.10. And so he's paying 1509.6. I have to put the 0 on it because it's money. So I'm going to calculate, I didn't put the 0 after this decimal point. Because I don't know that is money. You have to put the 2 decimal places because it's money. That's how money is written. So I don't want anybody to put this for money. Put the 60 there. But I go to that. All right. So if you got it by doing more work, no problem. But I'm showing you, you can get the same answer doing less work. You need to find a way to save time in the exam room. So it's the amount that you consumed right here times the rate. Let's continue. The next part says, for the next month of April, he paid this amount. Remember, his meter is starting right here, so now we know to start the next month. You know? That's where his meter is starting. All right? So that's where his meter reach. And he pays this amount. I remember he pays this amount at a rate at what? He paid that amount at a rate of $5.10. So if you divide this total by $5.10, you will know the total amount that he used in that month. And the question is asking us to determine the meter reading of the end of April. So the meter reading at the end of April is going to be the meter reading at the end of March. Let's set it up like this now. It's going to be equal to the meter reading at the end of March, which is this 03307. I'm just putting back the 0 there. It's immaterial, but I'm calculating what the final meter reading is supposed to be. Plus the amount that he consumed. The amount that he consumed is the total that he paid divided by the rate. So I'm just going to write it as a simple equation. 2351.10 divided by the rate of $5.10. So his meter reading is going to be the meter reading that he started with plus the amount that is added on to the meter. The amount of kilowatt hours that is added on to the meter is the money that he paid total divided by the rate. That's going to give me his final meter reading to simplify the calculation as much as possible. If you did more steps and get the same answer, no problem, but I have to teach you how to save time in the exam room. So I'm just going to do this calculation now. So it's really 3307, but at the end of it, I have to put the meter reading, I put the 0 in front. So it's 3307 plus a fraction of 2351.1 over 5.1. And so his meter reading is 3768. We put a 0 in front of it. That's his meter reading. Quick and fast, nice and easy. But to go to that, that's why question 1 can be done in 10 minutes or less. I can simplify a lot of calculations that way. Now, if you did it another way and you work out the meter reading and then add it, yes? So the question is, what did you get when you divide that? Let's see what that's supposed to be. 2351.1 divided by 5.1. Sorry, my mistake. Divided by 5.1. Supposed to get 460. 461. 461 this is supposed to work out. And then you added 461 to this. And so that is the answer. Huh? All right, so I'm asking for the meter reading, right? So let's look at the meter reading up here. So this is the meter reading. That's the value of the meter reading. You put the kilowatt hour neither here nor there, but I think this is the meter reading. If you look at the meter, you're not going to see the kilowatt hour. You're going to see these values. Question asking for the meter reading. If you notice our space out the digits, just to see him, look at it. Space amount. If I was not showing the meter reading and showing them, and I would maybe write 3768 like that. But I'm showing it as a meter reading, so I even space out the values and I make sure that I put the 0 in front of it. But I go to that. All right, good. Let's continue. All right, I don't need the calculator now. So this question says, we have to factorize the following expression completely. All right. So here I see 2 terms. So I'm thinking about the difference of 2 squares. I'm also thinking about common factor. Right now, it's not the difference of two squares. So first, you're going to go for the highest common factor, and then you have to look to see if what you get in the bracket, you have to factorize any further, because the question said completely. So initially, in terms of the values, the numbers, highest common factor is a 6. So I'm putting that first. In terms of the variables, I have y squared here and I have y here. So y is also a common factor. 6y is therefore your common factor. Bracket. If I divide 6y out of this, I'm left with y. If I divide the 6 out of this, I'm left with negative 3. If I divide the y out of this one, the y gone, I'm left with the x. And when I look inside here, that can't factorize any further, and therefore I'm done. That is it. But okay with that? Good. Next one. This clearly knows the difference of two perfect squares. But this can be written as a perfect square. So this initially becomes 2m all squared minus 1. If you remember that 1 is a perfect square. What's the rule? Let's write the rule. For difference of two squares, it is a squared minus b squared equals a minus b times a plus b. When you matter at a higher level, you do the difference of higher powers, like the difference of 2 cubes. Difference of 2 any powers. Got the difference of 2 powers. But anyway, let's continue here. And then this becomes 2m minus 1, 2m plus 1. What about that? Mark your book. You get it right? And I get this right. You get the factorization right. Huh? You have work to do. You got work to do. Everybody should be getting factorization correct. Questions correct. That's where you need to get your show marks. Factorization and those questions. All right. Then I have this factorize again. Now look here, I'm not going to do the mathematics, it's difficult to do when it's easy. Once it's a quadratic, right? And once my n values are prime numbers, I don't need to go through this lengthy process of factorizing. Because the only factors of 2t squared is 2t and t. And the only factors of this 2, this value 2, is 1 and 2. So those are the only values I'm working with. All I know, remember, is that when I put up my brackets like this, the far product and the near product must give you the middle term. The far product and the near product must give you the middle term. All right? So the factor of this one first can only be 2t and t. Then the factors of this is 1 and 2. It doesn't matter where you put the 1 and where you put the 2. Now because I see this 3 right here, and this minus tells me that it is the difference between the far product and the near product that gives me the middle term, the difference. So if the difference is 3, I need to put 2 with 2 over here and 1 there. So this is now 4t and this is 1t. The difference between 4t and 1t is 3t. So they are positioned in the right place. Now, the greater product must have the same sign as the middle term. The greater product must have the same sign as the middle term. When this last value is negative, it means that the two signs in the bracket are different. One will be positive and one will be negative. But the greater of the two products, the far product and the near product, must have the same sign as the middle term. Right? Because remember, you're adding them to get the middle term. So the middle term is negative. The larger of the far product and the near product must be negative like the middle term. So for it to be negative, it means that I have to put the negative over here to make the far product negative 4t and put the positive here to make the near product positive 1t. Then the negative 4t and the positive 1t gives me that middle term. Those are the factors right there. You have to practice and learn to do them this way, especially when the values are prime. When the n values are prime, there's no need for the lengthy process when the n values are prime. And the only factors of 2t, as I said, 2t squared is 2t and t. Only factors of this 2 is 1 and 2. You get me? So those are the only values that can appear in this factorization. All right? So that is that. Next one. This one wants us to write this as a single fraction. To write this as a single fraction, I want to make them related. I want the two denominators which are now different to become the same. So it's very easy. I'm going to multiply this denominator up here and down there. And I'm going to multiply this denominator up here and down there. And that will make the two denominators the same. So like I'm multiplying this fraction by 4 over 4. I'm multiplying this fraction by 3 over 3. That's how I'm making the adjustment. So that the two denominators become 12. All right? Watch this now. This becomes equal to, I'm multiplying the numerator by this 4. So I'm getting 20p plus 8 over 12, because the 4 times 3 here is 12, minus, I'm multiplying this 3 up here now. So I'm getting 9p minus 3 over 12. But understand that? But good at that. Then it really works out to this numerator minus this numerator. So we have to be careful with the negatives now. Careful with the negatives. All right, watch it now. So the answer is going to have the same denominator as 12. But when you're adding fractions now, or subtracting fractions, the same denominator, they are now related, you get by the same denominator. You just need to be careful in adding the numerator values now. So watch this now. It is 20p minus 9p. 20p minus 9p is 11p. Mute your mic, please, online. Mute your mic. Mute your mic. Jesus, peace. All right. So that's 20 minus 9 is 11. So that's 11p. So the trick part here now. 8 minus a negative 3. Minus minus will give you a plus. So you get plus 11. Very good. Plus 11. And that is it. All right. Now, if you want to factorize the numerator and put it instead as 11 into p plus 1 over 12, that's fine. But I feel like if you give that alone, they give you the marks just the same. All right. If you leave this as the answer, that's fine. 2 marks for doing that. Beautiful. Now, if you didn't do it this way, get the same answer, no problem. All right, let's continue. Just make sure you get the right answer. This question now. Last one, the class is being recorded. You can go and watch over the video later. We don't have time for stuff for you to stop and write. We're not going to do. Did you do the paper? Huh? So make your point for write off, boss. Right? You go home and you watch the video and you write what you want to write. All right. This question now says, we're doing that. But I said in the group that we're going through the paper and you leave the paper. I said that what we're doing. And I also said in the group, bring your paper to the class. I said it to them. They don't follow instruction. Can't tell excuse, man. That's the problem. I mean, excuse because if you not get learn, we have to learn. Do the right thing, man. Get with it. We have a WhatsApp group where we share a lot of information. You have to get the information. If you don't have phone now work, ask somebody. We're searching another group. Ask somebody. Be responsible. I'm always giving information in the group. So if you don't have your phone and you're not getting information, search anything in the group. Let me see where search in the group. And you look. Come on, man. But they will put excuse. That not help you. All right. So this question gives us D as this formula, whatever that is, right? It says calculate the value of D when the H is 29. So we're going to put 29 for the H right there. Simple as that. And then put it in the calculator. So we're going to get that the D becomes equal to the square root of 4 times 29 all over 5. All right. We can just put that in the calculator quick and fast and see what we get. So it's the square root of a fraction of 4 times 29, and we're dividing that by 5. It's giving me 4.8 something. It's to give the answer to 3 significant figures. Let's work that out now. So initially, we are getting 4.816637 8 and so on, right? Let's talk about the three significant figures thing now. So we'll work it out. So the three significant figures are the first three non-zero values from left to right. That's why you get a significant figure. The first significant figure in a number is the first non-zero value when you read a number from left to right. So this is the first significant figure. This is the second one. This is the third one. So these are your three significant figures that you want to correct the answer to. Using this 6 to correct those three. 6 will increase that 1 by 1 and increase it to 2. So this becomes 4.82 to three significant figures. That's the answer right here. All right, 4.82. Next thing we're asked to do is make H a subject. So let's look at it. So the D initially is a square root of 4H over 5. First thing you want to do is move the square root. You want to get rid of the square root. Inverse of square root is the square. So it's almost as if we're squaring this side and also squaring that side. And the square will sort of wipe out the square root. We don't have to show all of that, right? We just know so we square both sides. And so we're going to get that D squared is now equal to 4H over 5. And then to leave the H alone by itself as a subject, you multiply up the 5 and divide under the 4. All right? Multiply the 5 and divide under the 4. So we're going to get 5D squared over 4 equals H. But I get that? That is H as a subject. But let's just write it with H on the left side. So to present our answer, we're going to just turn it around and write 5D squared over 4 as our answer. It's the same thing, we'll just turn it around to put the H on the left side as the subject. The subject is always on the left side. And that is it. 11 marks for that question. 2 questions down, 9 to go. All right. Let's continue. Next question. Next question is a set. I've decided last year I didn't do set questions on the paper tools. I'm doing them this year. So I set it on the paper on the multiple choice. So we need to get comfortable with the sets just to see. All right. So let's do them. So this question says the universal set is this. Remember the N stands for natural number. This is a symbol for is a member of. So all this is saying is that X is a member of natural numbers. So natural numbers don't include like decimals like 2.1 and 2.3. Yeah, 4 numbers starting from 1. Natural number starts from 1. Because these are the numbers that you count naturally. And you count naturally from 1. 1, 2, 3, 4. Those are your natural numbers. All right? So, this natural number does not include 2. So, if I were to list them out for myself, and I go up to 12, if I were to just help myself and list them out like this, actually list them out, it will start at 3, because it says X must be greater than 2. So, it starts from 3, and it's also less than 12, so you don't reach 12. So, it's basically 3 up to 11. So, it's 3, 4, 5, 6, 7, 8, 9, 10, and 11. If I were to list them out, I think it's more friendly to list them out. You can see what you're working with. Then it says, M and R are 2 subsets, where M are your odd numbers. These are the odd numbers in these. And R are your square numbers. Your square numbers in those. The square numbers are like perfect square number, like 4 and 9 and 16 and so on, right? So they want us to list the members of M. So M would be your odd numbers. So it will be 3, 5, 7, 9, and 11. Then they want us to list the members of R, and R are your squared numbers. So R would be just the 4 is a squared number, and the next one is 9. But go to that, 4 and 9 are your squared numbers. Remember, if 1 was in there, 1 would also be a squared number, right? 1 squared is 1, right? Good. Next one says we have to draw the Venn diagram now. So let's go. We're going to draw the Venn diagram. So we always put a rectangle to start the Venn diagram. Then U is the universal set. You put it out there somewhere. Some people put it over here. Some people put it side. Some people put it here. Don't matter. Just put it somewhere out there. Then there are two subsets that we're working with. Right? A subset M and a subset R. Is there any intersection? Yes. Let's mark the intersection. So we have 9 here and 9 there. So only that one value in the intersection. So because we know that they intersect, I'm going to draw them crossing each other like that. I'm going to call this one over here M, call this one over here R. And then all values must be accounted for. Let's put them in now. Put in the intersection first, which is 9. Then to complete R, I just need to put the 4 inside here. That's the only other value. 4. Then to complete M, I need to put in these 3 values and this one. So it's 3, 5, 7, and 11. 3, 5, 7, and 11 coming here. 3, 5, 7, and 11. But you're not done yet. You have to account for all these values. Must be accounted for. All the values. So any value that not yet accounted for goes outside here. All right? So we have 3 already. We have 3 already. We have 4. We have 5. We don't have 6. So put in 6 out here. We have 7. We don't have 8. We have 9. We don't have 10. So basically, these are the even numbers that are coming out here. So it is 6, 8, 6, 8, 10. The reason why 4 ended up here because it was a squared number, even but it's also squared. And so we have accounted for all the values there. All right? And that is supposed to be your Venn diagram. And we can do is count them off just to make sure. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 values. Must have 9 values accounted for down here, which is 5 and 1, 6 and 3, 9. All right, so that is it. Done. But I go to that. But okay. Next question. This one wants us to construct a square of side 6 centimeters. I'm going to use the construction app to do it. Where are you? Right here. All right, let's do this. What's happening here? Got it. All right. All right. Now, normally, I always say to the students, sketch it before you construct it. Right? So, they want us to construct a square of side 6 centimeters. So, that's a square. 4 right angles, and all sides equal 6. And then the angles are 90 degrees, right? So let's do that. So let's put down a line 6 centimeters to begin with. Let's use a ruler. Let's put it here, put a line 6 centimeters. I'm just going to measure 6 centimeters on this ruler. No, that's not correct. Six centimeters. And because I said we have to construct it using these things, I can just use, for example, a protractor. I have to use a compass, that's what it said, right? So we construct 290 degrees, one at either end of that line. All right, so let's move the mold up. Mute your mic, please. Mute your mic. All right, so I'm going to construct a 90 degree over here, over this end, and a 90 degree on the other end. Let's do the construction lines in red. All right, so to construct a 90, plenty of people use different methods. The method I use is to construct 120, a 60 and a 60. Then I bisect the second 60 into 30, 30. Then the first 60 and the 30 gives me the 90. That's the method I use. So another way to do it, no problem. All right, so I'm gonna do my 120. So I draw a long arc because I need a 120 degrees. So I draw a long arc over here. Then I move the point and I cross that first arc right there. And then I move the point again. Hold on. And then I'm gonna make another cross. The thing shift. Let me start over. Let me start over. But I didn't lock the compass. I have to lock the compass. So let me start over. I have to lock the compass, guys. I didn't lock it. Let's go again. All right. So I lock it this time. I'll make a long arc, longer than 120. Move the point to here. Cross that first one. It move again. Why it move? Keeps moving. I don't know why it move. Let's see if we can set it back. All right. I'm going to move the point to here. And I'm going to make a second mark. So what I have there now are two 60-degree arcs. Right? Two 60-degree arcs. I'm going to bisect the second one. Second one is the one on top here. Right here is the second one. So to bisect that one, I come to this end of it, rotate it up, and make an arc in the middle, somewhere there. I put the compass over this end of the 60-degree arc, and I'm gonna cross this one again. And that's my 60-degree. All right. I'm gonna come at this end and do the same thing. I'm gonna make a 120-degree arc again, like that. Come to this point, cross that one, come up at this point, right at the intersection. And I need to cross that one, not long enough. See, that's why I need a long arc. So we'll come back down here. And rotate this back to cross this one. All right. So I have 263 arcs here again. I need to bisect the second one. So I'm going to move it and put it here. Rotate it up. And make an arc somewhere at the top there. Move it to this end, other side of the arc. Rotate it around. I'm going to make another arc there. And all I need now are two 6-centimeter lines through there. All right, 2 6-centimeter lines. So I need a line up here. Look how I'm gonna get the 6 centimeters. I'm gonna draw a straight line up there, right to the intersection. Let's go back for the black and mark off the 6. I'm gonna come through here, through that intersection, and that. I'm gonna draw another one through this intersection. You can use a ruler and just draw it one time, right? But it's kind of awkward with this device. I'm gonna do it this way. I'm gonna use a compass to get the 6 centimeters. All right, so I'm going to use the compass and get the 6 centimeters. I'm going to bring back the ruler, measure the 6 centimeters on the ruler. All right, so put me 36 centimeters, lock it, That's 6 centimeters. Let me change the color. And I'm going to mark off where the 6 centimeters is. Put the point here. Rotate the compass. And that will mark my 6 centimeters for me right there. That's 6 centimeters. Do the same thing over this end. That also is 6 centimeters. So when I join those 2 points now, like that, that's my square. And I constructed the 290 degrees, mark out my 6 centimeter lines. You can see them, the construction lines in blue. You have to show those construction lines. See how you get your information. All right, that finishes the first part. That's my 6 centimeter square. You can write on the 6 centimeter on it. So for example, you can leave it up like this. So this would be wrong thing. Let's use blue. So right here would be A, B. So they want us to do on a construct. Let's do the sketch first. Let's say it's A, B, C, D. They want us to construct an extension on your drawing to form a trapezium DABQ. DABQ. Q must appear so. All right, so I can leave it like that. So we're doing a trapezium DABQ such that the angle ABQ is 120 degrees. So we're putting Q up here. The trapezium is forming, so this will extend out there. And then this angle is going to be 120 degrees. 120 degrees. But we already have the 120 degrees mark on this construction. The 120 degree, let me show you with the compass. The 120 degree was up to this point right here. That's 120 degrees, you know. So if I draw a straight line through that, what I can do is extend this top line. Let me extend it for you. All right, let me draw the 120 degree line first. Let me draw the extension in another. Let's draw the extension in blue. So I'm going to draw the extension in blue through this intersection, extend it up. That's a 120 degree line, you know. And then if I take this line and extend it out, this original line that I have, let's draw it in blue, and extend it out. I don't want to go to there. I want to come to here. It's automatically going to put that point, but you get the picture what I want to do. It's automatically going to go to the end. Let me see if I cross it, right? Like that. That means that right here is Q. Right here is Q. So that is A, B, C, D. And right there's Q. That's a construction. And this angle right here is 120 degrees. Let's mark it in red. This is 120 degrees. That arc is 120 degrees. All the way over to here. That's 120 degrees. 260 degree arcs makes 120. And so that is my construction. All right? That is that. Then someone must measure and state the length of BQ. Measure and state the length of BQ. So to measure and state the length of BQ, we can use this thing and put it on the ruler. So put 1 point here. In the other end, out to here to the intersection. Lock it. Bring in the ruler. And move it and measure it on the ruler. I can just use the ruler and measure it still. But let me see what I'm getting. Anybody did it? Anybody did the question? You should get around 6.8. Anybody did it and got 6.8? Huh? If you have 7, they'll give it a marks, yeah. If they have 7, they'll give it a marks. But what we could do is actually calculate and see what the more accurate answer. But I won't get into that now. 6.8. All right, based on my construction here. All right, that is that question. Good. But okay? What good at that? Yeah?
Yes, sir.
I tell you what, we're going to see that until we do the class. When we do the class on construction, I'll answer that question. Because we just want to focus on the paper today. All right? So, we'll do the construction topic, you do it. I know we haven't done this topic before, but we're eventually going to do it. All right? It's a one-day topic, really, or a two-class topic. All right, let's go. This next question now, number 4, is a functions. All right. So, it says the function is defined as this, and I want us to calculate f of 3 plus f of negative 3. So, this becomes equal to f of 3, we'll put the 3 in there first. So, you get a third times 3 minus 2. This plus, we're going to do the f of minus 3 here now. By putting minus 3 there, it's going to be a third minus 3 and then minus 2. I can see that this value and this value cancel out each other. They cancel out each other. Because this becomes a 1 and this becomes a negative 1. So you're really left with negative 2 and negative 2. So the answer here is negative 4. That's the answer for that one, negative 4. All right? No, you can't lose marks on these things, you know, them too easy. You see, you all need to practice more. If you're losing marks on these, you need to practice more. All right. Let's continue. Next one is for us to calculate x for which f of x is 0. And it was a young man who run up of me. You know, come I'll send a picture of him, mother. I'm sleep in the classroom. Nah, foolishness. All right. When our head said fast asleep in the class. You never want to come to class with a sense. You see, when if you tell him to take him picture, whenever wake him up while I'm asleep. Huh? I mean, never. I take this thing for a joke, you know, and then when I walk and tell people, so don't come and Mr. Shaw class. Then I tell you, so don't come and Mr. Shaw class, come sleep. Anyway, next question. F of x equals 5. Find the value of x for which f of x is equal to 5. Now remember, f of x is this. 1/3 x minus 2. 1/3 x minus 2 is equal to 5. 1/3 x minus 2 is equal to 5. We're basically trying to solve for x right here. Transpose the 2 first, we get a third x equals 7, and then multiply the 3, we get x equals 21. 7 3 is 21. Nice and easy. Good. Next one. Determine f to the minus 1. Now remember, f is a third x minus 2. A third x minus 2. All we need to do is inverse this thing. This f becomes x. A third, this x becomes f to the minus 1, the inverse function, range of the inverse function, minus 2. And then we're trying to make this a subject. Move this 2 first. We're going to get x plus 2 equals a third f to the minus 1. Let's shift it over, see? Do have a lot of space, guys, to do a lot of work. You don't expect it to do too much work to get these things. Then to get rid of this third, we just multiply 2 by 3. I like to multiply this 3 across this side. So what's going to happen next is that we're going to get 3 times these values. So we're going to get 3x plus 6 equals f to the minus 1. And that is it. You can say, i.e., f to the minus 1. Okay, I'm putting in by the of x now. Of x is equal to 3x plus 6. That is it. 3x plus 6. If you put 3 times x plus 2, that also is good. Because we could have multiplied the 3 by all of this as one term. Either this or this, whichever one you write, still correct. I am in class. I am in class. I'll call back afterwards. All right. Next question. So this one now gives 2 lines, L1 and L2 on a graph. I like these questions because the calculation significantly reduced when you have the lines. You can actually see the lines. It says the graph below shows 2 lines, L1 and L2. Line 1 intersect the y-axis at 0, 1. right here. So that's the C value on line 1. C value on line 1 is 1. Line 2 intersects the X and Y axis at 12, 0 right here and 0, 6 right there. So everything that they are saying is also on the diagram, on the graph. All right, what do they want us to do now? Calculate the gradient of line 1 and line 2. So for line 1, we don't have to actually calculate. We can just count them off. Line 1. You just need to find 2 points and count the rise and count the run. Simple as that. So for example, look at the scale. First, every unit is 1. Because this would have been 7. This would be 1. This would be 3. Right? So every unit is 1. Every interval is 1 unit. Let's put it that way. So if you take, for example, these 2 points on line 1, this is the rise, which is 2 units, and this is the run, which is 1 unit on line 1. Right? So we can write that. Gradient of line 1 is 2 over 1, which is equal to 2. Then the gradient of line 2, M2. Let's do line 2 now. That's this one. Again, we're going to choose 2 points. And we can use this point, for example. Let's look it up. I'll zoom it up. Any 2 points, guys, that you know that you can count. This point to this point. This one is going to have a negative gradient. Remember, you go from left to right. Go from left to right. When you count in the rise and count in the run, go from a point on the left to a point on the right. So we would have to come down 1 unit here. So that's a -1. And you're coming down, and you would run 2 units to get to there. So it's -1 over 2. It's going to line 2. Simple as that. -1 over 2. -1 over 2. Remember, gradient is rise over run. Gradient is rise over run. Remember that, right? Between any 2 points on the graph. Number of units rise. If it rises downwards, it's negative. That's gradient of line 1. That's gradient of line 2. Those are 2 perpendicular gradients, you know. Because if I multiply them, I get -1. Also, if I flip this one and change the sign, I'm getting that. And if I flip this one and change the sign, I'm getting that. So those are 2 perpendicular lines. They have 2 perpendicular gradients. So they are 2 perpendicular lines. But let's see what else they want us to do. Determine the equation of line 1. So line 1, gradient is what? 2 we said. And for line 1, the y-axis intercept right here is 1. So I'm going to even put it on this diagram so CSEC see that where am I get my 1 from? I'm going to leave it on the diagram and say C equals 1. Or say C1 equal 1. C on line 1 is 1. So I'm going to write that here. C1 equals 1. The line 1 equation is y equals mx plus c, talking about line 1. So put the 1 there. So simply y equals 2x plus 1. That's the equation of line 1. Nice and easy. All right? Easy stuff. You don't need no calculation because the graph is there. You see the values. That's the answer right here now. That's it. Next one. It says, what's the relationship between line 1 and line 2? Give a reason for your answer. They are perpendicular because the product of the gradients equal -1. Simple as that. Line 1 is perpendicular to line 2. Reason is that M1 times M2 equals -1. Now, if you want to show the values, the M1 is 2 times the M2 is -0.5, them equal -1. That's the reason. When the product of 2 lines, when the product of a gradient of 2 lines is -1, they are perpendicular. That is enough. They are perpendicular because the product of the gradient is -1. Question done. Are you okay with that? Moving right along. Next question. All right. This one says, PTRS not drawn to scale is a quadrilateral. Q is a point on PT such that these distances are equal. You can see them marked out here. That's these 3 distances. And we know that there are equal distances on the diagram because they put these lines on there. So when they put those similar markings on lines, it means that they are equal in length. When they put arrows on lines, it means that they are parallel. All right, so those three lines are equal in length. So it means that this is an isosceles triangle. This also is an isosceles triangle. Now, plenty of people, for example, look at this isosceles triangle and figure out it is these two angles that are equal. Not so. Remember, the angles that are equal are the angles opposite the sides that are equal. So the angle opposite this side is 76. And so the angle opposite this side is also 76. So this angle down here is 76. This one is 76 degrees. All right, I know a lot of persons, because this triangle isosceles, these are the visual, and don't really understand the concept the right way, that it is the angles that are opposite the length that are equal, Say that again. The angles that are equal are the ones that are opposite the sides that are equal. Good? So it is not these two angles that are equal, even though it looks that way. All right? So get it right. In this one over here, this which is also isosceles, it is this angle and this angle that are equal. Why? Because this angle is opposite this side, and this angle is opposite that side. So those two are the ones that are equal. All right, let's answer the questions now. So first, we're going to put in this angle that we know is 76. Fill out the diagram. This angle is 76 degrees. All right? And the question is asking us for this one right here. All right? This one right here. So that angle, this angle is going to be 180 degrees minus 2 times 76 degrees. But can I agree with that? What was the answer? How much? 28? All right, I trust you. 28 degrees. Put on the diagram. This is 28 degrees. Now watch this now. I can tell you, without doing any work, that this angle up here so equal 14, and this one down here so equal 40. How do I know that? Huh? How do I know that I'm 40? All right, let me tell you how I know that I'm 40. Firstly, these two are the two opposite interior angles to this one. Right? So this one out here must equal the sum of those two. The exterior angle is equal to the sum of the two opposite interior angles. But them two happen to be equal. So the sum of them is 28 and they are equal. That means each of them are 14. See that? See that? All right. You have to learn do the mathematics the easy way. But let's see what I want us to do next. The next thing I want us to do is calculate angle PRT. Where's that? Angle PRT. PRT. That's going to be 90 degrees. It's going to be 14 plus 76. 14 plus 76. All right? So I know it's 90 degrees without him doing any work. But if you want to show some work, you could maybe calculate this angle right here. So total angle on a straight line is 180. So you're going to do 180 minus this one. And what you're going to get? 180 minus, you're going to get the sum of these two. Because this angle out here, so it's also equal to the sum of these two, you know. Same concept. 76 plus 76. That's 140 plus 12. 152. So this angle right here says 152. Agreed? Because it is 180 minus the 28, right? Angle on a straight line. And then these two equal 14 degrees. And so the angle that they asked us for is a 14 plus the 76. The angle that they're asking us for, you know, guys, is all of this angle, you know, the marked in purple. They're asking us for angle PRT. All of this angle here, so they're asking us for. All of the angle. Let me mark how I got the 152. I must mark it right here. So the 152 right here is 180 degrees minus the 28 degrees because of total angle on a straight line. And then we can say that these two angles, each of them, they are equal because the triangle isosceles, and they're equal to the 28, which is 180 minus 152, right? So that's why they are 14. So let me mark that this angle is half of the 28 degrees, right? Half of 28 degrees, that one. All right. And then the angle that I want down here is 14 plus 76. So this angle now that I want down here comes equal to 14 degrees plus 76 degrees, which then is 90 degrees. All right, next question says, SPT, angle SPT is given, must calculate angle SPT, given that angle SRT is 145, let's put it on, and PSR is 100, let's put them on. So SRT is 145. Where's that angle? SRT. SRT is 145. So let's put in the 90 that we just got here. The purple angle is 90 degrees. But they are now telling us, let's use a different color. So a different color for all of this. This green angle, all of this green angle. Where am I gonna put it? Where am I gonna put it? Where am I gonna put it? All of this angle between these two sides, this angle. They're telling us that that green angle is 145, right? That's what it said. Angle SRT. SRT is 145. That green angle is 145 degrees. So that angle is 145 degrees, and this is 90. It means that this remaining piece here, which we're going to put in blue, right here, is 145 minus 90. How much is that? 55, right? That's 55. Huh? 195, 145 is the whole thing, and all of here so is 90. So 145 minus 90 is 55. So this angle inside here is 55 degrees. Let's put over get it. It is 145 degrees minus 90 degrees right here. I can put a work on the paper like that as well. That's 55 degrees. And also tell us that another angle, PSR is 100. PSR is 100. PSR, that's right here. They're telling us that is 100 degrees. This now is 100 degrees. And so these two add to 155. And maybe they want us to find this one down here. Let's see. Let's see what they want. They want us to find angle SPT. SPT, where is that? Angle SPO. All of this, SPT. So first, to get angle SPT, we need to find this angle here first. That angle becomes 180 minus 155. Talk to me, what is that? 180 degrees minus the sum of these two, which is 155, which is 25 degrees. And then the angle that I want now is SPT, which now is the sum of these two, mark it in green. They're asking us now for this angle, SPT, which is the sum of those two, the 25 and the 14. All right, so we can write that 25 plus 14. So angle SPT is 25 degrees plus 14 degrees, which is 39 degrees. Everybody got that on the test? All right, that is that. Remember, any question you got wrong, you need to go and redo it. But I would a joke. Go and redo the question. All right. Next question. Transformation. Diagram below shows triangle ABC and its image A prime, B prime, C prime under a single transformation. So we go from this to this by a single transformation. But the first thing I'm observing is that there's a turn. So for example, BC, which was this way, is now BC this way. So it's a turn of 90 degrees, a 90-degree clockwise turn. But you can say that question is where is the center? Now, most times the center of these rotation is the origin. So I'm going to check if it is the origin. So for example, I can draw a line out to B and out to B prime. That will be 90 and the two lengths will be the same. So okay, looks right. I can draw a line from the center, from the origin, sorry, out to C. And draw one out to C as well. Those two lines are the same length as well, because it is 3 by 1. This one is also 3 by 1. And then I can test the same thing on A, simply in a crude way, but it works. A is rotated up to here. That looks like 90. And this length is the same. Oh, no. Because this length is 4 by 1. And this one is also 4 by 1. So I can conclude that the center of rotation is the origin right there. So it's a 90-degree clockwise rotation about the origin from this to this. Easy. Clockwise 90-degree rotation about the origin. One was clockwise because I just use one side. So for example, I could use, for example, B to A. B to A was this way. And B to A is now this way. So you see the head rotate up that way, 90 degrees, it rotates. It was horizontal and it's now vertical. So it rotates 90 degrees clockwise. It's not complicated. So it's a 90-degree clockwise rotation. But that's what I want us to do. It says, describe complete transformation that maps the original triangle to the prime triangle. See? A clockwise 90-degree rotation about the origin. Now listen to me now. If you leave off this part, you're not going to get the marks. When you're describing a rotation, it's 3 things you have to state about the rotation. You have to state the angle of the rotation, which is what I've done here. You have to state the direction of the rotation. You have to state the center of the rotation. See here is a rotation. It has 3 components. Now, instead of saying clockwise 90 degrees right here, guys, we could have instead say minus 90 degrees. Because clockwise rotation is negative. Clockwise rotation is negative. So could have said a negative 90-degree rotation about the origin. Clockwise rotation is negative rotation. Right? Sounds far-fetched, but that's how it is. That's a standard in math. Clockwise rotation is negative. When you do maths at a higher level, add maths and so on, that information will resonate with you even more. The clockwise rotation is negative. So instead of saying clockwise 90 degrees rotation, you could have said a negative 90-degree rotation. But if in doubt, just give the clockwise. But the problem is that they have set questions in the past where they give the positive and the negative in the answer. And you have to know the clockwise rotation negative and anti-clockwise rotation positive. You have to know that. All right? So every time I get the opportunity to remind you, I will say it. Clockwise rotation negative, anti-clockwise rotation positive. All right, next question. He said we have to do a translation on the prime triangle and name it double prime. And we're doing this, 4 negative 5. So 4 negative 5 means 4 units to the right. And this negative 5 means 5 units downwards. That's what 4 negative 5 translation does. They're going to move each point on the triangle, on the prime triangle, 4 units to the right, 5 units downwards. Remember, it's going to move. It's not going to change size or anything else. All right? Let's do it. The prime triangle, 4 units to the right, 5 units down. That's this one. 4 units to the right and 5 units downwards. Do it 1 point at a time. So this point, for example, A. 4 units to the right. Make sure that each box is a unit, which it is. Each box is a unit, because here will be 3. All right, so we want 4 units to the right. So that's 1, 2, 3, 4 units to the right, 5 units downwards. 1, 2, 3, 4, 5. So this point is coming here. That's where the A double prime is going to be, right here. Let's put down in blue. That's A double prime. And look here, since we know the size of the triangle, we can draw back the same triangle with the same size, around this point, So this length, for example, was 3 units down to B. So we can just draw a line 3 units down to B. That is where B would be. And then C was 2 units across from B. So we can just draw a line now 2 units across from B. That is C, and then you complete the triangle. Stop talking, man. You can't shut up your mouth, man. Stop talking. Yes? Huh? I'm on the chat that I can't hear. All right. I wonder why is that. If this mic is going. Can you hear me now? Anybody there? Anybody there not? Anybody there hearing me? Let me ask it that way. Anybody in the chat hearing me? Anybody in the online hearing me?
Yes, sir.
Yes, sir.
So you say whosoever can't hear, check your device. If you can't hear, check your device. Whosoever can't hear. And this is being recorded, so if you miss anything, you just check back the recording. All right, so that was 4 units to the right and 5 units downwards. 4 units to the right, -5 means 5 units downwards. That's what we did. All right, so we did 1 point and then draw the same shape around that 1 point. So this is going to be the double prime. Let me put them on as the double prime. So this is double prime, double prime, double prime. That is it. Nice and easy. All right, that's a double prime triangle. Question done. Next one. Number 6. Number 6 is a circular measures, and you know because they're telling us what we must use pi as. Diagram below not drawn to scale shows a field in the shape of a sector of a circle center O, and the diameter is 28. We don't work with diameter, so I'm going to write the radius is 14 from now. We don't work with diameter. All right? Everything we tend to work with radius. So if the diameter is 28, then the radius is 14. Write that down from now. All right? 14 meters. 14 meters. It says we have to calculate the area of the field. Right here is 90 degrees. So that's actually a quarter circle, That's just a quarter of a circle, If the angle here is 90 degrees, they will just have a quarter of a circle. So we don't have to say 90 over 360 times pi r squared. If you want to do it that way, well, fine. But if the angle is 90 degrees, then we really have a quarter circle. Well, we can work it this way. It's going to be a quarter anyway. So the area of the field, since the sector angle here is 90 degrees, it's going to be 90 over 360 times pi r squared. The 90 over 360 is a quarter. The pi is 22 over 7. And the radius is 14. So multiply that by 14 squared. Someone can tell me what that is? And they never do the test. I never get this right on the test. All right. So the quarter 0.25 times 22 divided by 7 times 14 squared. I'm getting 147.84 meters squared. Let me see if I get to that fraction. This fraction. All right, let's leave it as that. Got that one as well? Anybody got that one? Anybody else got that one? Nobody got that one in the test? I'm gonna get that one in the test. Area one sector, theta over 360 times pi r squared. Hit over 360 times pi r squared. You guys need a lot of work. You need a lot of work. Next part says the perimeter. So the perimeter is this radius plus the arc length. Perimeter is the distance around the shape. Perimeter is the 2 radii plus the arc. The arc is a fraction of a circumference. So it's 3 over 360 times pi r squared. That's a quarter circle. So it's a quarter of a circumference. Let's set it up. So the perimeter becomes the 2 radii, which is r plus r. Let me just write 2r for 2 radii. 2 times the radius plus the arc. So it's 2 times 14. The arc, let me write a formula for the arc over here. The arc is going to be theta over 360 times 2 pi r, fraction of the circumference. This theta over 360 becomes a quarter because it is 90 over 360. So I'm going to add this 90 over 360, just becomes a quarter, it's a quarter circle, times 2 times the pi is 22 over 7, times the radius is 14. Put all that in the calculator one time. You don't have a lot of space to be doing a lot of calculations. So it's 2 times the 14 here, so give me 28 plus this becomes a quarter. Let's work it out step by step, which is 0.25 times 2. Well, I just put a half there, so but all right. Times 22 over 7 times 14. 50 meters flat is the perimeter. 50 meters flat. Anybody got that 50 meters? Huh? All right, good. Next question. That is the topic that we just came off. We actually did a question like this in the classwork. As you look at this, you see that it has a 6, 8, 10 triangle, don't it? So this side automatically is 8 centimeters, right? You must recognize that. 6, 8, 10, Pythagorean triple. All right? But let's answer the question. It says, diagram below, not drawn to scale, shows a triangular prism ABCDEF. The cross section is a right angle triangle ABC, where AB is 6 centimeters across here, and the hypotenuse is 10 centimeters. So right here is 8. Question says, calculate the area. To get the area, we really need this side is 8. I'm going to put on the diagram right here. I didn't ask me for it. I'm going to put that this side is 8. I'm going to say this side is 8 centimeters. I'm going to show some work for it. It is the square root of 10 squared minus 6 squared. Pythagoras' theorem equals 8. I'm putting it on the diagram. Right? So let's see how I get my 8 that I'm going to use down here. Then the area becomes half base times height. The base is 6 and the height is 8. So the mathematics is easy way. This equals half 6 times 8. Half base times height. That's 24 centimeters squared is the area of that triangle. Good? Nice and easy. Let's continue. Question said, the length of the prism with the volume is this. Now remember, volume equals end area times length. We know the end area already. We just work it out up here. Let's call the end area A. So now we want to find the length of the prism and divide by the area. So we can say, therefore, the length of the prism is the volume over the end area, or the cross-sectional area. So that becomes, the volume is 540 over the area that we just calculated up here is 24 over 24. 540 over 24. That becomes the length of the prism, L. So we're just going to divide 540 divided by 24, 22.5 centimeters. 22.5 centimeters is the length of that prism. Nice and easy. Are we good with that? All right. Next part wants us to give them the total surface area. Once it's the surface area, it is total surface area. So remember now that the total surface area is the area around the side of the object, which is called a curved surface area, because a prism plus the two ends, 2 times the end area. The curved surface area is simply the perimeter of the end times the length. Perimeter of the end times the length plus 2 times the same end area. The perimeter of the end is what? 6 plus 8 plus 10, note it? 6 plus 8 plus 10, that's the perimeter of the end. 6 plus 8 plus 10. All right, so this becomes equal to 6 plus 8 plus 10, that's the perimeter of the end, times the length. The length is this 22.5, we just worked it out. 22.5. And then we're adding 2 times the end area. The end area is 24. So it's 2 times 24. Work out all of that, and you were good to go. All right? So I'm going to write out everything. So it's 6 plus 8 plus 10, close bracket, plus 10, close bracket, times the length, which is 22.5, plus 2 times the end area, 2 times 24, which is 48. So the total surface area is 588 centimeters squared. That is the total surface area. Nice and easy. Doing the mathematics the easy way. Every time. That is it. Very good. All right. Moving right along. Next question. All right. Next question is a statistics. Statistics question. Number 7. It says, table below shows the speed to the nearest kilometer per hour of 90 vehicles that pass a checkpoint. All right. And the data is grouped. So now everything we're doing now is estimate. Once the data is grouped, we're doing estimation statistics. They have started the cumulative frequency column for us. So let's just finish it. I'm sure they're going to ask us to finish it. But they ask us some questions first. So for the class interval 20 to 39, that's this one. For that class interval right there. First question is, what is the upper limit? The upper limit is the n value as appeared in the table. That's 39 kilometers per hour. 39 kilometers per hour. Put on the units for me, please. Don't just write 39. All right, the data is in kilometers per hour. What is the width? The width is the upper boundary minus the lower boundary, but you can see the width from here. All these lower limit values changing. It's going up by 20. See that? So I know it's 20. These are also going up by 20. But if you're not sure, it is the upper limit, upper boundary, sorry, minus the lower boundary. So if you were to calculate, you're still supposed to get 20. So it will be 39.5, that's the upper boundary, minus the lower boundary is 19.5. The upper boundary here is 39.5, and the lower boundary here is 19.5. The width is the difference between the upper and the lower boundary. It's going to work out to the 20 kilometers per hour, just to see. And you could know the boundary by just seeing all these lower limit values are increasing, all these upper limit values are increasing. You can see it that way as well. So it's 20. Next one says 16 vehicles, that's this cumulative frequency, 16 vehicles pass the checkpoint in no more than what? The upper limit value is really the upper boundary value, you know. This question kind of wrongish a little bit, or the word it. Because really, the cumulative frequency, right, here, is really saying 16 vehicles pass in less than or equal to 39. Right? Or it would be less than 39.5. Right? Because all of these vehicles down here will be going at a speed of less than 39.5. And it is 16 of them, the 5-year and the 11-year. Makes 16. That's what the 16 represent. Right? So this is kind of worded poorly because it said no more than. So no more than means No more than means less than or equal to. So I guess it's the 39. No more than 39. That's no more than the 39. So that means less than or equal to. So it's going to be 39, the upper limit. So 16 vehicles passing no more than 39. No more than 39 means 39 or less. So that is it. All right, so it's 39. All right, remember, for the cumulative frequency, guys, you're either plotting a less than or equal to graph or a less than graph. If it's a less than or equal to graph, you'll be doing less than or equal to the upper limit value of the 39. If it's a less than graph, then you'll be doing less than 39.5. But this statement really is for no more than 39 means less than or equal to. So it is the upper limit that I want. Upper limit that I want. All right. That is it. All right. Next one. It says complete the table by inserting the missing values for the cumulative frequency graph, cumulative frequency column, and then I want us to draw the graph here. Let's just complete the column by adding up the frequency now. So this gonna add 26 to this. So it's 16 plus 26. How that work out to? 42. Then add 37. So it's 42 plus 37. What is that? 79. Then add 9 to that. So it's 79 plus 9. What is that? 88. And then add 2 more. 88 plus 2 to account for all 90 vehicles. All right, that is it. And then I want us to draw a graph. All right, and it's must use 2 centimeters to 20 kilometers per hour on the x-axis and 2 centimeters to 10 vehicles. And we have to use this graph under here. But I have another one on the screen here. Let me bring it up. So we can be looking at the table and the graph at the same time. So let me do it on this one over here. Right here. All right, so we're going to have to scale up the graph. Let's look smaller and draw the graph on the right side of the screen. All right, so basically plotting these upper limit values. Extend it up like this. Against these cumulative frequency values. So we're plotting a less than or equal to graph because of this information, that line. This is what they asked us. So we're gonna do a less than or equal to graph. All right, and everything going up by 20. Now, you do have to complicate it, you can actually put in these actual values, because they tell us to use 20 centimeters, right? So they tell us to use 20 centimeters. All right, so the value, all right, let's do what the value. The value before 19. These going up by 20. What will be the value before 19? So subtract 20, don't it? It will be -1, no? That's all? -1, right? -1. And -1 would have cumulative frequency of 0. But that was not in the data. Remember, you know, the first vehicle started at 0, meaning like it stopped. What do you think the -1 would have mean in real terms? A speed of -1. Means that the vehicle reversing past the checkpoint. Technically, that's what it would mean. Reversing, going backwards past the checkpoint. All right. So we're gonna draw a graph. I'm just thinking of the scale because everything is going up by 20 to make it easy for myself. But the question is, what information they ask us? They ask us some information. All right. Let's do it by 20 then. All right. Let's say 2 centimeters to 20. So let's say we start here. Let this be our 0. Reason I'm making that our 0, guy, because I want to bring the graph down to negative. Bring the graph down to the x-axis, which has to go down onto the x-axis at -1. If we're going up by 20 at all times, right? So I'm gonna put it right here. So we start right here, right? And put this as our 0. And it is 2 centimeters to 20, so it's 1 centimeters to 10, right? So this will be 20, 40, 60, 80, 100, and here will be 120. I wouldn't go past 120, right? 120. So those will be my X scale. And that I'm doing a less than or equal to speed. I'm doing a less than or equal to graph in kilometers per hour on the horizontal axis. And then I'm putting the vehicles up here. That's cumulative frequency. I'm putting the vehicles up here. And the scale I must use is 2 centimeters to 10 vehicles. So I'm gonna do, this will be 10 vehicles. 10 vehicles. But this is my y-axis, you know. This become my y-axis right here because this is my 0. Right, so here will be negative 10. Right, here will be negative 10. I'm going to show you why I'm doing that. So here will be my y-axis, will be this line. All right, so I'm going to put my y-axis here. This becomes my y-axis. And it's 2 centimeters to 10 vehicles, I said, right? And the total number of vehicles was 90. All right, so already know. So this is 10, 10, 20. I'll put it on the graph. Let's put it here. 10, 20, 30, 40, 50, 60, 70, 80, right here will be 90. All right. So this is now my cumulative frequency, which really are my vehicles, my number of vehicles. My number of vehicles. I'm basically going to plot those points in red now. Right? Plot the graph, information in red. So let's plot these points first. 19.5. So what we have to do now is recognize based on the scale, where would 19 be? Where would 19 be? What is each of these small lines? Here will be 10. So it means that each of these small line is 2. So that will be 12, 14, 16, 18. So it means that 19 will be right on this line right here. That will be 19. That will be 19, right? Right there. That will be 19. All right. So and 39 we're right here. So we know where we're going. So 19 going up to 5. So 5 is right here. 19, 5 is right here. This will be a 5 line. Then the next point will be up here, 39, see there, 39, 16. So 16 would be right here. This is 15, 16 with this line, 16. So this is the 16 line, and this is the 19. So talking about this intersection right here is the next point. All right. And the next point we're going up at 59, 42. 59, 42. 59 is on this line, sorry. 59 is right here before the 60. That's going up to 42. 42 would be right here. This will be 42. This line is 42. So 42 is on this line. Coming across to here where it meets the 59 line. So we're talking about this point right here. All right. The next one is here. 79, 79. 79, 79. So 79 would be right here, right before the 80 line. 79. I'm going up to 79 on the y-axis as well. So 79 will be right here with 79. So talking about this point right here, the next point. All right, that's what we're looking so far. The next point we're doing is 9988. 9988. So 99 is going to be just before the 100 right here. So the 100 here. So we're talking about up here. That's where the 99 will be. We're going up to 88. That's it. 99 line. I'm going up to 88. 88 will be right here, just before the 90. Let's zoom up on it. 88 is this line. So talking about this point here. All right. And the last one is 119.90. 119.90. So 119 is going to be 1 unit over. I can say it's 1 unit over here. This will be the line for 119. See it here? That's the 120 is right here. All right, so 119.90. So 90 here, so talking about this point right here. And those are the points for your graph. See them there? But then I want to bring the graph down to 0 on the x-axis. You must always bring it down to 0. So look at the values again. If these going up by 20, and you're starting at 19, the value before 19, you subtract 20, you get -1. So if you go to -1, 0. And if you even look at the pattern of the values, if you see it's basically ouch. You're basically going just before each of these 20 centimeter marks. So the one that will come next will be just before this. Just before this. So you're talking about you go on the x-axis right before the origin. There. That's where the -1 would be. All right, and you're drawing a smooth curve through those points now, which is going to get the ogive shape for the cumulative frequency curve. Let's draw it. Something like that. That's cumulative frequency curve. I'm working with that curve. All right. And if I ask about this point down here, you basically say no vehicle reversed past the vehicle at reverse past the checkpoint at 1 meter per second. But the negative means that you'll be reversing. And the number of vehicles here is 0. So no vehicle passed the checkpoint at -1 meters per second. In other words, no vehicle reversed at 1 meter per second past the checkpoint. That's what this point means. If I should ask it, technically that's what it means. But let's answer the other part now. It says, on your graph, draw reference lines to estimate the speed at which no more than 50% of the vehicles drove past the checkpoint. Now, 50% of the vehicle means 45 vehicles, you know. That's 45 vehicles. So you come up on a graph and find 45. It's 45 here, so. Let's do that part in purple. This is 45. 50% of the vehicle is 45. It's almost like they're asking to find the median. That's 45. You come across the graph. Looks like it's right on this mark. And that mark will be right in the 60. 60. I'm getting 60. Right here. So what is that speed? 60 kilometers per hour is that speed. At 45, 50% of the vehicles passing no more than that speed. That's it, 60. 50% of the vehicles here is 45 vehicles. That corresponds to a speed of 60 meters per second on the graph. So what is that speed? 60 kilometers per hour. That's that. But to that, all right. Kind of question kind of lengthy, but that's how it is. All right, next question. Number 8. It's supposed to be a pattern. I need to copy this over here. See if I can copy this over here. Hold on a second. Let's see if I can copy this over here. All right, good enough. All right, next question. Pattern question. They give us that pattern. It says the first 4 figures in a sequence are shown below. Figure 1 is a single dot, while each of the other figure consists of black dots arranged in an equilateral manner. So you basically can observe is like they added these 2 to the bottom of this one. Then they added these 3 to the bottom of this one. Then they added these 4 to the bottom of this one. So the next one we need to add 5 onto the bottom of this one. So for to do the next one, it will be bam, 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 bam. That will be my next shape. And then I would fill in these now if I were to form my next shape and use this to help me to get my next shape. So it's like the 4th shape, and I just add these 5 dots on the bottom of the 4th shape. And I can move this into place. That's my figure number 5. Right there, nice and easy. That will be my figure number 5. What are we good at that? Next question says, how many dots in figure number 6? The figure number 6, how many dots do you have here, sir? How many dots do we have here, sir? We have 5, 4, 3, 2, 1. Right? And the next figure, you have to add 6 more dots on the bottom of it, don't it? To get figure number 6. So this is how we can calculate on the exam paper and write this in. 5 years, so 4 years, so 3 years, so 2 years, so 1 year, so far. And then we have to add 6 more. We have to have 6 more on the bottom to get this figure. So this will add up too much. This is 21. So the answer is 21. Huh? 21.
Yes, sir, 21.
21. So this will be 21. 21. Done. And I'm leaving this on the paper now to show I got it. Right? Next one. Next question says, the table below refers to the figures and the number of dots in each figure. Study the pattern shown, and then I want us to complete the rules for figure 11. Complete the rule for figure 11 right here. So first, I'm going to do this one first. Even though I ask for it last, I'm going to do this one first. All right? So if I look at the pattern, I see half starts it. I'm going to put a half times this number is always the figure number. So it's half n times this now is the figure number. So it's always the figure number plus 1 in the bracket. So it becomes half n plus 1. So it's half the product of n and 1 after n, right? So the question is I must complete this row now. So the figure number is 11. So it's going to be half times 11 times 11 plus 1. And what will it work out to? We're going to put what it works out here. How much is it? 66. 66. That's it. Good. It says determine which figure in the sequence has 210 dots. So all I have to do now is put this equal this formula and see what the n is, right? All right, let's be smart about it now. So we're gonna put half n plus 1. Look at it now, half n plus 1 equals 210. Multiplied by the 2, we get n times n plus 1 equals 420. So how am I going to figure it out now? I want the product of two numbers to be equal to 420. So because the product of two numbers that are consecutive must equal 420, we can start out by square rooting the 420 and say what would the square root be? And it's going to be the number below the square root value and above the square root value. All right. So I'm just going to do it that way. All right. So the square root of 420. So it means that I want 20 and 21, right? So 420, therefore, the product of 20 and 21. That's 420. And therefore, the figure number is 20. So n equals 20 is my answer. If you do it another way and get the 20, no problem. But n is 20. Figure number is 20. All right? 420. 420. That's it. It says, write a simplified algebraic expression for the number of dots D in figure N. Is this the mountain or this? Half n plus 1. That's it. That's the number of dots in figure number N. Show that no diagram has exactly 1,000 dots. So I'm going to do is put half n plus 1 equals 1,000. And so n times n plus 1 equals 2,000. Then we're going to try to find n the same way again. So we're going to square root 2,000 again. That's what it would be. Square root of 2,000. And we get 44.7, right? So then I'm looking for 44 times 45. That would be 44 plus 45. If it would work, if I check 44 times 45, I'm getting 1980. Or it could be 45 times 46. So this equals 1980. But then 45 times 46, which product of two consecutive numbers again. 45 times 46 is passing the 2,000. 2,070. So I can say something like, let me show you. I'll show you how you could put it. All right. So based on this, I can say something like, firstly, n has to be a natural number, right? I can say there is no n which is a natural number such that n times n plus 1 is equal to 2,000. That's why there is no n for the number of that to be 1,000. Understand that way? Understand that proof? That's not the only way you could do it, but that one works as well. Right? That one works as well. Understand that proof? So basically saying, look, I'm trying to find the value of n that will make this equation be equal to 1,000. Get me? So when I reduce it, it came down to this. N times n plus 1 equals 2,000. That's a product of two consecutive numbers must equal to 2000, and those two numbers must be whole numbers. So I'm going to try 44 times 45. I'm going to get 1980. Then the next two consecutive numbers to try is 45 and 46. That gives me 2070. So them jump over 2000. So therefore, there is no two consecutive numbers that are whole numbers where the product is 2000. And so there is no n that will cause the number of dots to be 1000. Right? Or what you can, another way you could do it, you know, you can work and show what the n would be. You can work what the n would be for just before 1000 and for just after 1000 dots. That's another way you could do it. And show that there's no whole number n that's going to give you that number of dots, 1000 dots. All right, well, that's how I would present it, like that. All right, let's go. Next question. All right, this one we don't do this topic yet, but we're going to run through it still. All right, it's a velocity time graph. All right. Now, two things about this velocity time graph you have to know is that gradient on a velocity time graph is acceleration, and then area under the graph is distance traveled. Gradient is acceleration, area under the graph is distance traveled. All right. So this one gives us this velocity time graph, show the motion of a cyclist over a 40-second period. This axis is the speed, or the velocity axis, this axis is the time. Question says, calculate the gradient of OA, that's this line. It simply rise over run, and it gives you the acceleration. The rise is 10, so the gradient equals rise over run, which is 10 meters per second over the run is 25 seconds, right? Time in seconds. Over 25 seconds. So that actually works out to 10 divided by 25, 0.4. 0.4, and you have to write this now. Because it is acceleration, you're going to write meters per second squared. Because actually, once you calculate gradient on a velocity time graph, is acceleration negative. So you have to give them that unit, meters per second squared, 0.4. Gradient of AB. AB is a horizontal line, so the gradient is just 0. You don't need to calculate that one. Horizontal line must have a gradient of 0. Because the rise is 0. The rise is 0. So this becomes equal to 0 meters per second squared. Means that the vehicle is going at a constant speed. It's not accelerating. See it? It's going at one constant speed of 10 meters per second. So it is not accelerating. All right? Miss Madam, you paying attention? Next question says, complete the following statement. The cycle started from rest. Oh, no, it started from rest. But it started here when the speed was 0. Speed is 0, you're at rest. You're not moving. When the speed is 0, you're at rest. Started from rest, which is true. Right? Where the velocity is 0 meters per second. And steadily increases speed by how many meters per second per second? That's the acceleration. That's a 0.4. 0.4 was how fast he's increasing its speed, the acceleration that they get. So increases speed at 0.4 meters per second every second. See? For each second during the first 25 seconds. So that's the acceleration here. That acceleration is how fast he's increasing his speed. How fast are you increasing the speed? That's the acceleration. That's the value that we calculated here. All right? So it's 0.4 meters per second per second. It said during the next 15 seconds, that's up here, when it was going at a constant speed. Acceleration is 0. During the next 15 seconds, the velocity remains constant. That is, its acceleration was 0 meters per second squared. So you see we're using up the values that we used in the first part. It said determine the average speed of the vehicle. The average speed is the total distance over the total time. And the total distance is the area under the velocity time graph. So the total, the average speed, let's write it, average speed equal total distance traveled, total distance over the total time taken. But this total distance on a velocity time graph becomes the area under the graph. Area on the graph. The area under the velocity time graph still over the total time. So the question is, what is that area under the graph? It becomes the area of this trapezium right here. This trapezium that I'm shading out. See, the total time is up to 40. You have this trapezium here. What's the area of the trapezium? It is half the sum of the parallel sides. We mark out the trapezium here. We're trying to find the area of this thing to get the distance traveled. The area under here, under that trapezium. This side is 40. This side up here is 15. From 25 to 40 is 15. So you'll get the values, you know. Up here says 15. Then the distance between those two parallel sides is this 10. This length here, so it's 10. The 10 across here. So use those values for the area. Half the sum of the parallel sides multiplied by the distance, the perpendicular distance between the parallel sides. I'm right over here, so that area, which is the distance traveled, becomes equal to half the sum of the parallel sides. I put over this side. The area, which is also the distance, is equal to half the 15 plus the 40. As the sum of the parallel sides, times the distance between the parallel sides is 10. That is what you use to get the area of that trapezium, which is the distance traveled. Let's copy this down. Now let's just work out what it is and use the value. So that becomes, write this out for me. That is what? This is 55 times 5, because half of the 10 is 5. 55 times 5. 275. So 275 meters is the total distance traveled. That is the area under the graph. 275. So let's go back down and put the 275. So this becomes equal to 275 meters traveled over a time of 40 seconds. That's what we're working on. 275 divided by 40. So it was going at 6.875 meters per second. That was the average speed. All right. Anybody got that? Anybody got that? Yeah, you know what is funny about these extra classes sometimes? It's like any topic that I bring up that I don't do, another can do. Serious. Any topic that I bring up and say, let us do this topic. I don't do this topic yet, you know. But you can never do it. Someone that want to learn at school. Serious, man that want to learn at school. Any topic I bring up, but me don't do in this class. You can't do it. Must learn on a regular school too, man. Let's go. Let's go. No problem. We're gonna do that topic. We're gonna do that rates of change topic as well. So don't worry about it. All right. This question says, consider the following pair of simultaneous equations. If you look at it, this one is a curve, this one is a line. Curve and a line. Remember, generally speaking, we're solving simultaneous equation of a line and a curve. We tend to substitute the line equation into the curve equation. So for example, this one is the line one. Oh no, this one is the curve one. Obviously the x squared and the xy there. But so the curves usually come, the curve equations usually have products and quotients of the x and the y. Products and the quotients of the x and the y are usually in those. The line equations can be written in the form y equals mx plus c. Line equation, right? So this one is a line. I will normally make y the subject of this one, for example, and put that y equals 3 minus x. 3 minus x. And I will take it now and substitute it to the curve right here for this y. That's how we normally solve them. All right? I'm going to get a quadratic. When we get a quadratic, solve them simultaneously, we're going to get 2 points. Most times they get in 2 points. But that's a curve and that's a line. So it's like you have a curve like this and you have a line and they intersect at 2 points. You get in 2x values and 2y values, right? All right. Well, let's see what they want us to do. It says without solving the equations, show that this point is a solution. So if that point is a solution, it means that it satisfies both equations. It means that the point works on both equations. If the point works on both equations, it means that it is on both curves. It is on the curve and it's on the line, and so it is a point of intersection. The coordinates of the point into both of them and show that it works. So I want to put it in the curve first. 1, 2, substituting it into x squared plus 2xy equals 5. What we're going to get? We're going to get 1 squared plus 2 times 1 times 2, which is equal to 5 for 2. This is true, don't it? So, see that? I'm going to put it in the line now. 1, 2. I'm going to put it in the line, which is x plus y equals 3. It's going to be 1 plus 2, which is equal to 3. This is also true. See that? So since the point satisfies the two equations, what I mean by satisfy? When you put the coordinates in the equation for the x and the y, it remains true. It works out true. It is consistent. The values are consistent. Because this side works out to what the result is, 5. And this side, the 1 plus 2 works out to 3. It is true that when you substitute the coordinates in the line, it works. When you substitute the coordinates into the curve, it also works. It means that the point is a common point to the line and the curve, and so it is a solution. Right? So because that is so, we can say it is a solution. And that's all you have to say. It is true for this and it is true for that. Therefore, 1, 2 is a solution. That's all you have to do. Simple as that. Show that it works on the line. Show that it works on the curve. Next one says, solve. You're marking your work. Solve the pure simultaneous equation above to determine the other solution. So now they want us to solve it. We know one solution already is where x equals 1 and y equals 2. They want us to find the other one. So we're going to proceed to solve them. So we have the curve. We're going to basically write them out. Let me write them out for you again. So it's x squared plus 2xy equals 5. I want to write the line instead as this. Y equals 3 minus x. Y equals 3 minus x. As a line on a curve, I'm going to substitute for the y. So I'm going to take this, the line is saying y equal to, and bring it and substitute it for the y in the curve right there. All right? So let's say that. I'm going to substitute the line into the curve. Sub line into the curve. That's the method that we're using, the approach. And what we're going to get? We're going to get x squared plus 2x into 3 minus x equals 5. But understand that? You substitute for the y. Because at the point of intersection, the y values are the same, you know? So the line is saying y equals 3 minus x. So the 3 minus x is the same value on the curve. That's why you can substitute it in the curve for the y. Because at the point of intersection, the x values are the same and the y values are the same. So we're trying to find the point where the y value on the line equals the y value on the curve. And that's why you can make that substitution. You understand? And then we're solving this now. And it's a quadratic. So this expands out into x squared. So don't give a lot of space, guys. I keep telling you. X squared plus 6x minus 2x squared equals 5. Then this and this is minus x squared. Let's write it minus x squared plus 6x equals 5. I'm going to transpose everything over onto this side, make it positive. So I'm going to get x squared minus 6x plus 5 equals 0. But I say that? If I transpose this over here, it becomes a positive x squared, see there? Transpose this over there, it becomes a minus 6x, see there? And this plus 5 is already over there. I could have put the equals 0 here, so you know. But I choose to put it here instead, same difference. Then I factorizing this. I already know one factor has to be x minus 1. Remember, one of the values that we get was x equals 1 for this point. This point that they gave us, x equals 1. So I know that x minus 1 is one of the factors. So the other factor has to be x minus 5. Because this is a positive 5 at the end. So the far product and the near product must give it the middle term. So those are the two factors, x minus 1 and x equals 5, x minus 5. So the other point is where x equals 5. But this factor is going to give me x equals 5. But understand that? This factor is giving me x equals 1, which we deal with that already. The other point the question is asking us about is where this now equals 0. So let's put it here. The other point is where x equals 5. Other point that they're asking us for, the x is equal to 5. I'm going to plug the 5 in the line equation there. So the y is equal to 3 minus 5. Y is equal to negative 2. So the other point is 5, negative 2. 5, negative 2 is the other point. This is my answer right here. 5, negative 2 is the other point. I don't have to work out the first point because we have it already. The question asks me for the other point. So I'm focusing on the other point. Understand that? I'm not going to work the question over again. It's exam question, past paper. These are things that you can do. You just have to practice them. It's just like they ask you to solve the simultaneous equation and they would normally leave it at that. But sometimes they put the sugar on the questions and they kind of change it up a bit. But the same thing you're doing. Normally you have to solve a simultaneous equation and find the 2 points. This time they give you 1. They give you 1. And say, show us that this is 1. No problem. And then say, find the other one. So you don't have to find the first one because they give you that one already. The focus is on the other one. Normally down here, they didn't give us 1. This factor would have given us x equals 1. I would have plugged the x equal 1 right here, so in the curve, the line equation. And the y value would have been 2, because 3 minus 1 is 2. And you have got that point 1, 2. But if we waste time working that out again, because I gave you that one already, your focus is on the other one. The question is asking you for the other point. Sit there and I put it in bold letters. Because I know one already. So once you got these two factors, x minus 1 and x minus 5, you know that this is the one giving you the x equals 1. That's for the first point that I gave you. The other point is where x equals 5. So we wrote the other point. X equals 5 over here. That's what we did over here, the other point. All right? So that is that. We don't need to go work the question over again. Number 10. 2 more questions to go. Number 10. Let me take a sip of agua. All right. Circle theory. Center rule. Angle at center is twice. Diameter rule. Angle subtended by diameter is 90. Same segment rule. Angles in the same segment are equal. Tangent and radius rule. Angle between a tangent and a radius is 90 degrees. 2 tangents rule. Only 2 tangents can be drawn from a single external point. 2 tangents are equal in length. 2 tangents and the 2 radii forms a cyclic quadrilateral. Cyclic quadrilateral rule. A cyclic quadrilateral is formed when you have 4 vertices of a quadrilateral and the circumference of a circle. The opposite angles are supplementary. They add up to 180 degrees. Then we have tangent and chord rule. The angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment of a circle. Those are the main rules for circle theory. Listen about the video and listen to what I have said. All right? Stuff that you know already. Let's go. This question says PQRS are 4 points of the circumference of a circle. So it means that this is a cyclic quadrilateral right off the bat. That is a cyclic quadrilateral to begin with. All right? It says the angle up here is 58 degrees. See here, that is 58 degrees. That angle of circumference is 58 degrees. It is subtended by this chord. So this chord is subtending 58 degrees up here. Watch this now. The same chord is subtending its angle at the center. So right out the back, this angle is 2 times 58 degrees. But the angle at the center is twice angle of the circumference. All right? Let's continue though. It says using geometric properties of a circle to give reasons for this for each step in your answer, determine the measure of angle SPQ. All right, SPQ, this one. So them two here supplementary, don't it? The opposite angles in this cyclic quadrilateral. Cyclic quadrilateral rule. All right, so it is 180 minus a 58. So this angle is 180 degrees minus a 58 degrees. What I work out to? Minus 50 first, we get 130 minus 8 more, we get 122. No, sir? 122 degrees. That's this angle right here is 122 degrees. Because opposite angles in a cyclic quadrilateral. This is 122. Because this is a cyclic quadrilateral, guys. It means that these two opposite angles, they add up to 180 degrees. They are supplementary. All right? Let's write the reason. Let's write it. See here, opposite angles in a cyclic quad are supplementary. Meaning that they add to 180 degrees. That's what supplementary means. All right, that's the reason for that one. Opposite angles in a cyclic quadrilateral, they add to 180 degrees. All right, that gives us the first angle there. What else I want? The one angle OQS. Let's mark it on the diagram and see what it is. OQS. OQS. That's this angle. Now, we have to remember now again that this is an isosceles triangle. Why is it isosceles? Because that's a radius. That's a radius. And so these two angles equal. This angle and this angle equal. But then we can find this one. It is 2 times that one. All right? That angle is 2 times that one. So they didn't ask for it. I'm going to put it on the diagram as my solution. So I'm going to mark it on the diagram here. And just say it is angle SOQ. Angle SOQ is 2 times 58 degrees. Which is 116 degrees. And then now, because this angle is 116 degrees, if I know one angle in an isosceles triangle, I'm blessed. I can find the other two. But the total is 180, right? And then these two equal. So let's do it down here. Down here, I'm going to say that angle that we want is equal to 180 degrees minus the 116 degrees divided by 2. That's all. What I work out to? 32 degrees each, right? Reason is that total angle in the isosceles triangle. Let's put a triangle symbol. In isosceles triangle, total angle is 180 degrees. So by saying it is isosceles, is justification for dividing by the 2. It means that 2 of the angles equal, right? And the total angle is 180. That account for 180. And then the 116, we basically account for it up here. Put it on the paper. So the CSEC see it, it's on the paper. That's where we get it from. All right? We don't have to put the reason, because they didn't ask us for it, but we needed it to get the answer. But if you want to put the answer reason, you can put it to. Angle at center is twice angle at circumference. You can put it there. Let's put it there. Since I said give reason, so let's just state everything. So see here, angle SOQ is 160. Angle at center is twice angle at circumference. Yeah? No, them tell you, oh, tell you right so. Let me see, they didn't tell you. It's a point, they didn't tell you. But it's always a center. But they didn't say, but normally it's O. But normally they say it, you know. But this time they didn't say, but it is. It's a PQR circumference, a circle as shown below. Yeah, O is the center of a circle. It is a center. But this question didn't state it explicit, but it is the center. So that's a good question. Yes. O is the center. All right, bearings now. Let's go. This question says a ship leaves port A right here and sailed 52 kilometers on a bearing of 044 degrees to port B. That's this journey they're talking about. So it goes on a bearing of 054 degrees. Remember, it's from the north line clockwise. All right. So this is the angle that is 44 degrees. Let's put it on there. So I'm gonna extend this side up, extend this north line all the way up here. I'm doing that in the exam room too, you know, extending it up. Some people not pay attention, you know, not learn nothing. I'm going to tell you no matter, so I'm not coming for a joke. Because I'm serious time now, and some people don't realize, so them forget serious. You understand? Yeah. So it don't make no sense. Better not keep no money, stay on the yard. You get me? Coming in there foolishness. Every time I look on now green like it's a joke thing. You stay on the yard. You back on no matter no money, turn on the yard. Simple. To come off a joke. All right, so this angle is 44 degrees. It's 044 is the bearing, but the angle is 44. So did they say to show the bearing on it? No. Did they say to show it on it? Said on the diagram, it said label the known distances. That's right. Let's put the 044. All right, so this angle is 044 degrees. Can't take people in a serious, you know. Can't take people in a serious. I'm a joke. That's 044 degrees. The distance is what? The distance is 52 kilometers. Let's put that on as well. 52 kilometers right here. And then now it told us the ship then changed course and sailed to sea 72 kilometers away, and it went on a bearing of 105. That's this journey now. On a bearing of 105. So again, it's clockwise from this north line. So this is the angle they're talking about. Let's extend this line again. That's my north line. And I want a clockwise angle here now. This angle is 105 degrees. Let's put it in there. And the distance is 72. So I'm at the stage now where I have two sides. If I can find an angle in between here, then I'm blessed. I'll be able to use cosine rule to find this side over here. Get me? That's what these questions always is about. So did they ask for it? Let's see. But that's information to put on the diagram first. It says on the diagram, not drawn to scale, label the known distances traveled and the known angle. So that is it. So that's the known angle, that's a 44. All right. It said determine the measure of angle ABC. That's inside here. Angle ABC. Now this can be done multiple ways, guys. Multiple ways. We want to find this angle inside here. Yeah, it's a U angle. So that will be a U angle, and so we can find this angle over here, co-interior with this one, and then total angle around the point is 360. But another way to do it is to actually just break it like this. Just break it like this. Break it to that black line. Break it like this, the angle that we want. We want this angle across here now. Break it. And then what I'm now, to get it quickly, this half, you have a Z angle. You have a Z angle over here. So inside this says 44 like that one. That's alternate angles. So I'm going to put it in there, 44 degrees. So inside here is 44 degrees as well. And then on this side, I have a straight line. Total angle on a straight line is 180. And so this part of it is 180 minus 105, which is how much? 75. So inside this says 75 degrees. And so the total angle across here, which I'm going to put in blue now, is the sum of those two. See that? 75 and 40 is how much? 110 and 9, 119. That's right? That's it? 119. So we can write that. See the diagram as it? So I'm going to say this angle equals 44 degrees plus 75 degrees, which is 190. 119 degrees. All right? And I'm sure they're going to ask for AC now, because that's all that is left. Calculate the length of AC. We're going to use cosine rule for AC. Let's do it up here and then copy it down. So cosine rule for AC. Cosine rule for AC. It's going to be that AC squared equals this side squared plus that side squared. 52 squared plus 72 squared minus 2 times the 52 times the 72 times the cosine of the angle between them, which is the 119 degrees. So remember, cosine rule starts out like Pythagoras' theorem there. And then you subtract this piece. So it's easy to remember. You don't have to look at the formula sheet for this. Just practice with it and you get it. No, I don't want us to waste time. So I have to practice also to not waste time and put the square on this. Rather than put the square on that, you put the square root over everything here. So this is what I wanted to actually write in the exam room and don't waste time. And they put everything in here in the calculator all at once. And they write what AC is, quick and fast. You don't need a number. You don't need 5 lines to do this. And you have to learn to do the questions efficiently so we can get them quickly, get them correct, and do them quickly in the exam. All right, so you're going to put this in the calculator now exactly as it is. Make sure your calculator is in degrees. See the DEG up there. DEG is in degrees. So I'm going to write square root 52 squared plus 72 squared. You don't have to waste time working on each part. That's waste of time to be working on each part. Put everything in the calculator and get one value. Okay. Minus 2 times 52 times 72 times the cosine of 119. The only thing you need to do, make sure the calculator is in degrees and make sure you enter the values correctly. Get one answer, 107. 107 kilometers. And they always say to the nearest degree, don't it? See there? To the nearest kilometer, sorry. See there? So that is the solution for that part. I'm going to move it down here. That's it. Next part now says, show that the bearing is 260 degrees. Show that the bearing of A from C, watch this now, you have to be very careful with this bearing thing. Remember, bearing is measured at the from position, so you must always identify the from position. And you're doing the bearing from C to A. So the bearing is measured at the front position. I'm going to show that angle on the diagram now. Front position is C, it's from C to A. All right, let's go back to the diagram now. We're going from C to A. All right, so this is C, this is A. We're doing the bearing at this point. Let's set it up. All right, so we're working from this point. And since we're working from this point, the angle inside the triangle at this point will more than likely play a part in the calculation. More than likely, 90% of the time. I'm going to call it alpha from now. Should play a part in the calculation. All right, so let's mark the bearing that we want. The bearing that we want is from this north line at the front position. We want the clockwise angle. Let's draw it in purple. Clockwise angle from the north line to the line going down to A. That's the angle that we want to know right there. So it's a matter of figuring out how we get that angle now. Kind of easy because we almost complete in the full circle. We can get this angle inside here, that will help. And look, we can see the Z. This angle is 75, you know, or one way is 75. Two reasons. I can say these two angles are co-interior angles. So they add up to 180. So the angle down here is 180 minus the 105. Or you could see the Z down here, up here, down here, and up here. The alternate angle. So this angle and this angle equal. So anyway, we want to look at it, the angle inside here so is 75 degrees. The angle inside here so is 75 degrees. It's going to help us. So that purple angle that we want to know, that's the bearing angle that we want. So we're going to use the fact that the purple angle plus the alpha plus the 75 is 360. So the purple angle, which is the bearing angle that we want, is 360 minus the 75 and minus the alpha. We're going to have to find the alpha. See that? Let's call it theta on the diagram so we can reference it. So this purple angle that we want, which is the bearing angle, it becomes 360 degrees minus the 75 degrees and minus the alpha, which we're going to have to calculate. All right? I'm going to use sine rule to calculate it. We already know this side. Let's put on the diagram. Should have done that before. This side was what? What did we get? We got that side to be 107. Let's put on the diagram right here. This side equals 107 kilometers. And now that we have this angle and side opposite each other in the triangle, where we know both of them, we know the angle and we know the side, we can use sine rule to find the angles. The only thing we don't know are these two angles, you know, in this triangle, you know. So anyone we need to find now, sine rule will give it to us, right? Because we have this pair of angle and side opposite each other, we know both of them. Once you have that in a triangle, you can use sine rule. So this is how we're going to get that angle. 360 minus 75 minus alpha. And we're going to have you use sine rule for the alpha. I'm doing it right here on the screen with the diagram in front of us, just for the purpose of the lesson. And then I'm going to copy it down. Let me do it right here. The sine rule for the alpha. We need alpha. Sine rule for the alpha. So let's do it here. So sine rule for the alpha. Start with what you want. Sine of the alpha over the side opposite the alpha is a 52. Sine of alpha over 52 equals sine of the angle that you know. The angle that you know is 119 over the side opposite, which is 107. So it's sine of the 119 degrees over the 107 opposite to it. We'll take this 52 and multiply it up. And then to get the alpha, we're going to have to take the inverse sine after that. So tell me if you see this now. The alpha is going to be sine to the minus 1 of the 52 is up here now. So it's 52 sine of 119 degrees over 107. That's what we're calculating for the alpha. And then we'll get that value. We're going to drop it back in the equation there. All right, so let's do it. So we're going to get sine to the minus 1 of a fraction, 52 sine of 119 all over 107. That gives us 21.2 degrees. 21.2 degrees. 25.2 degrees, sorry. 25.2 degrees. I'm going to take this 25.2 degrees and put it here now to get the theta. So the bearing angle theta that we want becomes 360 degrees minus 75 degrees and minus the alpha, which is now 25.2 degrees. And you work out the theta, you're going to get the 260. So we're going to get 360 minus 75 and minus 25.2. And we get 259.8, which I said is approximately 260. We get 259.8 degrees, which to 3 digits is 260 degrees. And that is shown. I'm just going to copy this down now, this part of it. I'm going to copy this down now. Copy this down and set it up. How we need this, right? I'll cut it. Cut it. Let's cut it. Cut that and paste it over it where we need it. Down here. All right, so I'm setting it up here now. So based on the diagram, we said the bearing of A from C, I'm going to say is theta. All right, and we said that the theta was 360 minus the 75 degrees minus the alpha. Then we use sine rule for the alpha here. That's what we did here. So sine rule for the alpha. Then when we get the alpha, we put it back over here, and so we're shifting this up now. I'm basically filling back on the calculations. All right, so use back this alpha value back up here, and I just need to change this back to blue. And we'll be good. Sure. That's it. All right. That finishes that question. One last question. Nobody died. One last question. Nobody died. Let's go. Matrices and transformation. Let's go. Finish strong. Finish strong. 8 o'clock now. Let's go. Finish quickly. All right, so it says matrices A and B are those. Show by multiplying that AB is not equal to BA. Now, technically, you really only need to work out one of the values. You know? But I'm going to work out one of them fully. And you only really need to see one value different. So if I work out AB, for example, like this, then I'm doing 3254 times 403 negative 1. And if I start this one, remember we're taking the rows of the first matrix by the columns of the second matrix. And I'm going to get 4 values. So if I work out this first value first, it's in the first row and the first column. So to get it, using this first row with this first column, I'll multiply matrices again. First value in the row by the first value in the column. Second value in the row by the second value in the column. So we see first element times first element, second element times second element. 3 times 4 and 2 times 6. 3 times 4 and 2 times 3, sorry. 2 times 3. 3 times 4 is 12 and 2 times 3 is 6. So that value is 18, you know. Watch this now. If I just start now and do the BA, no, technically I'm not going no more. No. Technically I'm not going no more. Because I already know that this products, this one starts with an 18 right there. I don't put in these other values yet. When I start the BA, then it would be 4, 0, 3, -1 times 3, 2, 5, 4. Again, we are doing the rows of the first matrix by the columns of the second matrix. I'm going to calculate the first value. Here again, let's zoom upon it. So again, we have 4 values to get. The first value here, it is in the first row and the first column. So I'm multiplying this first row by this first column. First element times first element, second element times second element. 4 times 3 and 0 times 5. 4 times 3 and 0 times 5. 4 times 3 is 12. 0 times 5 is 0. So technically they're not equal already, you know. Because this is 12. Right? So this and this not equal. So even without me working out the rest of them, I have already shown that they're not equal. But the question is, will CSEC give you the marks for doing that? And not working out all of them? You don't, it's only 2 marks to the question. You know? We're going to multiply the 2 of them fully. You would have already, if you finish one, I don't need to finish the other one. Because by finishing one, I would have demonstrated to CSEC that I know how to multiply. And if one value in the matrix different, the matrix different. You get me? If one value different, in the same position, different. First row, first column value, different. Then the 2 matrices different. So technically, I should be able to stop right here and say that the matrix is not equal because the first value here and the first value here not equal. So it means that to him, 18 not equal to 12. Therefore, AB not equal to BC. Not equal to BA, sorry. I'm supposed to get my marks. But just to be safe, I would at least work out one of them fully. Now we start work out the 2 of them fully for 2 marks. Why? Because normally you only need to work out 1 for full marks. For 2 marks. It's only 2 marks. You get me? So I would do, if I do this, and I'm finish the paper, I have time, I come back and finish that. But if I'm in the exam room, I'm pressed for time, I'm stopping right there. Believe me, now I don't know more than that. But let's just finish one. All right? So I would stop it there. If I was in an exam, I'm telling you the truth. That's what I would do. Right? If I want to work it out, they must give me some instructions to work out the whole light. That's how I look at it. So I want to work it out fully, give me some instruction to work it out fully. Right? But I would have shown that they're not equal by showing that the first value not equal. But let's just complete one of them at least. Let's just complete one of them. All right. And then we're going to say they're not equal here. I'm not doing any more on this one. Just that first value is sufficient. I'm going to finish this one. Let's finish this one for practice. All right. So that first value is 18. All right, so this second value now, it is in the first row and the second column. So to get it, we're going to use this first row with this second column. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 3 times 0 and 2 times -1. 3 times 0 is 0. 2 times -1 is -2. Then this value down here now, it's in the second row, first column. So to get it, we're using this second row with this first column. First element times first element, second element times second element. First element times first element, second element times second element. 5 times 4 and 4 times 3. 5 times 4, 4 times 3. 5 times 4 is 20. 4 times 3 is 12. Then this last value down here is in the second row, second column. So to get it, we're going to use this second row with this second column. First element times first element, second element times second element. First element times first element, second element times second element. Ready now? 5 times 0, 4 times negative 1. 5 times 0, 4 times negative 1. 5 times 0 is 0. 4 times negative 1 is negative 4. So consolidate the values now. This becomes negative 2. This becomes 32. This becomes negative 4. So I've completed one of them at least. I'm not completing this one, I waste time. They're not equal already. So right here I'm going to say therefore shown that AB is not equal to BA. Why? Because 18 is not equal to 12. I don't need to go any further. Next part. Find A to the minus 1, the inverse of A. We should remember A again, this one, right? So A, let's write it over here. A is the matrix 3, 2, 5, 4. So we can reference it. Let's go. So what A to the minus 1 in blue? A to the minus 1 is 1 over the determinant of A times the adjoint of A. 1 over the determinant. The determinant is the first diagonal product, the 3 times the 4, which is 12. Minus the second diagonal product, 5 times the 2, that's 10. Multiply by the adjoint. Interchange the elements on the leading diagonal, that first diagonal. Interchange them. So we're going to put a 4 here and a 3 here. Leave these two elements on the second diagonal where they are. Change the sign. So this 2 becomes a negative 2 in the same position. This 5 becomes a negative 5 in the same position. This under here really is a 2. Let's put it in red. And so now you're dividing each of these values by the 2. And so finally, this inverse matrix, really then, this divided by 2 is 2. This divided by 2 is negative 1. This divided by 2 is negative 2.5. This divided by 2 is 1.5. So that is my A to the minus 1 matrix. A to the minus 1 matrix. Inverse matrix. It says write down, I have to calculate now. Write down the matrix product. The matrix representing this product. A matrix and its inverse equals the I matrix, the identity matrix for multiplication. So A times A to the minus 1 equals the I matrix, which is equal to 1, 0, 0, 1. You must know that. 1 mark for it, the 1 mark. A matrix times its inverse in any order. Doesn't matter, you're going to get the I matrix. The identity matrix for multiplication of matrices. All right, that's that. Then we come to this. Write a pair of simultaneous equations, matrices equation from these two. Easy. X followed by y, good. X followed by y. Easiest thing to do. Becomes the product of a 2 by 2 and a column matrix xy equals a column matrix 1, 5. Then the coefficients go into this 2 by 2 matrix. Easy. 3, 2. Everything positive. 3, 2, 5, 4. Everything positive. 5, 4. That's it. That's the matrix equation. All right. Is this the A matrix from up top? Let's see. Yes, it is. The same A matrix, right? Same A matrix, this. Then it says, write the solution of your matrix equation as a product of 2 matrices. Now, they're asking to solve them, you know. And so, write the solution as a product of 2 matrices. So, from this matrix, what happens now is that you have to take the inverse and put it in front there to make xy the subject. So xy is going to be equal to the 3254 to the negative 1. So I'm put in the negative 1 and the inverse times the 1, 5. But we already know the inverse of this matrix is this one that we just calculated up here. No, not that. This one up here. All right, that's the inverse. So we'll just copy it down. This is the inverse we need. Let's copy that down. I'm going to paste it down here. So it becomes the inverse times the 1, 5. And xy becomes equal to that. This is what they want to see down here. Let me just shift it down now. That's it. So this is the answer right here. Now this is the answer. This. That's the answer. This line is the answer. They say right at the product of two matrices. They never said to solve it. Question did not say solve. Follow the instructions. Right? They say write your solution as a product of two matrices. Then we say solve it now, but I solve it. Follow instruction. That's it. Next question. Vectors. Finishing strong. It says portion vector of points P and Q relative to an origin ORD. That's OP, that's OQ. This is P and this is Q on the diagram. It says the diagram below shows that PR is 3 times OP. This PR is 3 of this. Watch this. Watch this now. Watch this now. This vector here, so, is 3 OP. So it means that OR is 4 OP. Can you see that? And then QS right here is 3 OQ. So the vector right here, so, is 3 OQ. So it means then that OS is 4 OQ. See that? OQ and 3 OQ is 4 OQ. That's OS. It says express each of the following in this form. The OS is 4 OQ. Can you see it on the diagram? Let's write it. This OS is 4 OQ, which is equal to 4 times, what is OQ again? OQ is this guy right here, so 50, which then becomes 20. That's the answer. Then I want PQ. Let's look at the diagram now. PQ is OQ minus OP. O times the last minus O times the first. Why am I using this method? Because I know the position vectors. When you know the position vectors, then you use them to find the displacement vector. O times the last minus O times the first. The OQ is 50 minus the OP is what again? 3, 4? Or 4, 3? 4, 3. Soft with a capital T. 5 minus 4 is 1. 0 minus 3 is negative 3. That's a PQ. Next question. What are these vectors? RS. Same thing again. You know R, you know position vector of S and position vector of R. They didn't ask us for it. Oh no, so OR is 4 OQ, don't it? 4 OP, don't it? Let's write it up here, so. Let's write it up here, so. How we're gonna use it? OR is 4 OP. OP is this. So it becomes 4 times 4, 3, which then is 16, 12. So OR is 16, 12. So we know OR is 16, 12. Let's go now. So RS is OS minus OR. O times the last minus O times the first. S is the last, R is the first. O times the last minus O times the first. What is OS again? 20, don't it? 20 minus this one was what? 16, 12, right? 16, 12. This works out to be 4, negative 12. 4, negative 12. Then the two vectors then parallel, don't it? State two geometric relationship between the two vectors. Let's write them down. The PQ was what? The PQ was what again? What does get for it? 1, -3, don't it?
Yes, sir.
And the RS will get feet. 4, -12. It's clear that this one is the bigger one, don't it? It is equal to 4 times the smaller one, don't it? That's all? All right. Keep it simple. So we can write the big one RS equals 4 times the small one PQ, don't it? It means that they're parallel. I mean the RS is 4 times as long as PQ. See that? You can see it on the diagram as well. So RS also. So PQ also. Then parallel. And that one here is 4 times the length of this one. So the one two geometric relationships say that. 1, then parallel. 1. RS is parallel. We're not going. 2. PQ. Second relationship is how long one is more than the next, right? RS is 4 times the length of PQ. Done. And that is that. Watch me now. One how much can I get? One of them get more than 25. Who get less than 25? What I want to? Huh? 32%? All right. This one also gonna get more than 25. Watch me now, guys. Don't joke. This is the first one. We have 22 more to do. 22 more to do. All right? Watch me now. You have to go and redo all the questions that you got incorrect. Redo all the questions that you got incorrect. Because we need to see progress on the next one. Listen to me now. I'm going to send, we're breaking now. The next class is next week, Monday, after church, right? I'm going to send a paper in the group, 2 papers in the group. One for the Sunday group, one for the Monday group. I want you to do both of them. So it means that Sunday, after champs, same setup. In the class and online, we're working on that paper. Monday, same setup. In the class and online. So you have the whole week to do that paper for me, please. 2 papers. You have the whole week to do those 2 papers for me, please. All right? I'm going to ask the parents to ensure that they do them. So I'm coming to class next week to do them. The pass mark is still 25. Pass mark is going to be 30 the following week. I'll step it up each week. And the week before the exam, it's going to be 95. You must reach 95 by then. Learn from your mistakes. Redo everything that they got wrong. I'm going to send the video in the group right after. Everybody online okay? Everybody online okay? All right, see that they're gone. Mr. Jonathan?
Yes, sir.
You good?
Yes, sir.
All right. Elizabeth.
Yes, sir.
You all right?
Yes, sir.
Mr. Troy. Troy fell asleep. 120. All right, guys, I'm going to end it now. Bye. Do what I tell you. Work over the question you got wrong for me, please. Bye, everybody.